Now note on this problem, two sources are connected, 1 ampere current source and 1 volt voltage source, and 5 resistors are connected, 1 ohm, 1 ohm, 1 ohm, all the resistor values are equal values. Then find the current through this resistor, 1 ohm resistor, that is I value. So now the question is this question. This question is a previous competitive exam question, and the question is given, find I here. See, to find I from the given question, first we have to find out which method is the best method to find I here. Which method is the best method to find I, current through this branch. See, first I want to apply mesh analysis. See, to apply mesh analysis, immediately we have to find out individual loops. Then the number of loop equations depends on the number of individual loops. So here 1, 2, 3, 4. So the circuit has 4 individual loops are there. 4 individual loops, and here we have to apply 4 individual loop equations. Then the simplification becomes very difficult. So mesh analysis is difficult for this problem. And similarly later I am taking here nodal analysis method. So from the nodal analysis, first we have to find out number of principal nodes. So here one node, here one node, and here one node, and here one node is there. So 1, 2, 3, 4. Now it has 4 principal nodes. So according to the nodal analysis method, number of nodal equations is equal to n minus 1. So number of principal nodes 4 minus 1. So it requires totally 3 equations. Again, solving of 3 equations also very difficult. So for this problem, to find I from the given problem, mesh analysis and node analysis is difficult here. And some other techniques also there, source transformation. So we can apply here source transformation, and voltage source is connected. Again, it requires more number of equations. So for these type of problems, immediately we have to apply superposition theorem, because so to solve these type of problems analysis purpose, superposition theorem is the best technique, and it is an easy technique compared to the remaining all the techniques. See, one voltage source, 1 ampere, one current source is there. So the network is connected with more than the one source. So superposition theorem is applicable, and the complete network is connected with linear elements only. So linear elements are there. So according to superposition theorem, total response is equal to sum of individual responses. So first we require here individual responses. To find the individual responses purpose, apply one source at a time, remaining sources are eliminated. So now first I am taking current source here. Current source is applied, so current source is as it is connected. Here current source is as it is connected, and the remaining address is like this. Here one resistor is there, then one more resistor, 1 ohm resistor, and here 1 ohm resistor, 1 ohm resistor, then here another 1 ohm resistor. So remaining sources are eliminated. Remaining source is here voltage source. Voltage source acts as short circuit. So voltage source is short circuited like this. Voltage source is short circuited. Then find the current through this branch. This current is due to one source. So first source, that's why I am assuming this is I dash. And all the values are 1. So 1 ampere, 1, 1, 1, 1, 1 is there. So if the voltage source is short circuited, the complete network consists only one source, then find out the total resistance, then find the current through that branch. So that purpose, again I am writing the circuit here. So this, if it is short circuited here, if this point is short circuited here, these two resistors are connected in parallel combination, and these two resistors are connected in parallel combination, because these 2 points are short circuited. So after simplification, here it becomes these 2 are short circuited, means it becomes 1 by 2, and here again these 2 are short circuited parallel combination. So these 2 are also 1 by 2. One resistor is connected from this point to this point. So one more resistor is connected from this point to this point. This resistance value is 1 ohm. And in between these 2 points, one current source is connected. This value is 1 ampere. Then according to the given question, we want current through this branch. This is I dash. See, according to the analysis here, voltage source is short circuited. So this point is directly connected to this point. If these 2 points are short circuited, these 2 resistors becomes in parallel combination, and these 2 resistors also connected in parallel combination. So parallel combination, equal resistor values are there. So 1 by 2, here 1 by 2. Then find the current through this branch. So one current source is connected to the 2 parallel paths. One path resistance is 1 by 2. Another path resistance is how much here? 1 and 1 by 2. Both are added. So both are added. This value becomes 3 by 2. 1 plus 1 by 2 because these two are contained in series combination. So from this given network, I dash is equal to total current is 1 ampere into opposite resistance. Opposite resistance is here 1 by 2 by sum of the two resistors. Sum of the two resistors are 1 by 2 plus 3 by 2. So 1 by 2 plus 3 by 2, this becomes here 2 and here 1 by 2 is there, finally which gives the 1 by 4 amps. 1 by 4 is nothing but 0.25 amps. 1 by 4 is nothing but 0.25 amperes. So if only one current source is connected, voltage source is eliminated. So due to one source, the response of the circuit is 0.25 amperes. The response of the circuit is 0.25 amps. So this is due to one source. Similarly, we have to apply another source here. Another source is here, voltage source is there. Now voltage source is connected and current source is eliminated. Current source internal resistance is infinity, then the current source acts as a open circuit. So current source acts as a open circuit and draw the remaining circuit as it is. So here I am drawing the circuit, 4 resistor elements and one more element is connected here. So the current of this branch is now I double dash. 1 ohm, this source is also 1 volts, 1 is there. Now current source is eliminated, here current source is there, this path is acts as a open circuited. Now the network is like this. So current source is, we have to find out the current through this branch. This current is response due to second source, that's why I wrote I double dash. So I double dash. One voltage source is connected to these resistor. Now the given circuit is just like acts as a one bridge circuit. So easy understanding purpose, just I am writing names here, A, B, C, D. Just I am assuming nodes names here, A, B. In between A and B, one voltage source is connected. So I am taking A node is here and B node is here. A node and B node. So in between A and B, one voltage source is connected. And in between again another nodes are there. Those nodes are C and D node. So here I am taking A and here I am taking B. Now see, in between AC, one resistor, and AD, one resistor. In between AD, one resistor, and another is in between BC. B is connected here, one resistor, and in between BD, here one more resistor. And another extra resistor is connected in between C and D. So in between C and D, another extra resistor is there. Then according to the given question, we have to find out current through the 1 ohm resistor, this branch. So current from C to D. So the current from C to D. So this current we want here, I double dash. Now just observe the network. This network is acts as a bridge network. So in bridge network, immediately we have to check bridge balancing condition. Bridge balancing condition explains the product of opposite impedances are equal, right? So now 1 into 1 and 1 into 1 both are equal. Now the bridge is balanced. So already clearly explained. If the bridge is balanced, the current through the diagonal element is 0. Voltage across the diagonal element is also 0. Voltage in between these 2 points is 0 and current through this path is also 0. So just like it is acts as a open circuit. If it is open circuited, I double dash is 0 amps. I double dash is 0 amps due to second voltage source. So second source here. So due to current source, the response is 0.25 amps, and due to voltage source, the response is 0 amps. Then from the superposition theorem, total response is equal to sum of individual responses. I dash plus I double dash is equal to 0.25 here. 0.25 plus 0 becomes here 0.25 amps. So these type of problems, to solve these type of problems, superposition theorem is the best technique. It takes only few steps to solve this problem here, to find the current through one branch. See, according to the given network, mesh analysis is difficult here, nodal analysis is difficult. That's why immediately we have to apply superposition theorem. From the superposition theorem, at a time only one source is activated. So first initially current source is connected, voltage source acts as a short circuit. If the voltage sources are short circuited, these two elements are connected in parallel combination and these two connected in parallel combination, then the simplified network is like this. Then from this network find I dash. I dash is equal to, from the current division theorem, total current into opposite impedance by sum of two impedances. So sum of two impedances here 2. Then it gives the response, that response is 0.25 amps. Similarly, due to second source is here I am applying voltage source is connected, current source is eliminated. So current source internal resistance is infinity, so current source is acts as a open circuit, so current source is open circuited here. And the remaining network is like this. Again I draw this network, redraw the network means just we have to assume the nodes, then redraw the network like this. Then in this case this network is acts as a one bridge network. So in bridge network the current, if the bridge is balanced, current through the diagonal element becomes 0. So now here the given network is bridge balanced network, that's why I double dash is 0 amperes. Then from the superposition theorem, total response is equal to sum of individual response statement is there. So from that statement, here I wrote total current is equal to I dash plus I double dash, finally which gives the 0.25 amps. So to solve these type of problems, superposition theorem is the best technique here. So just note down, here I explained how to apply superposition theorem and what is the importance of the superposition theorem to find unknown parameters. So just follow the technique, same technique, depends on the number of independent sources, it requires number of circuits here, number of individual responses. Here two independent sources are there, then it requires two individual responses, one is I dash and I double dash. Okay, so please note down the solutions of the given problem. This is another competitive exam question. The question is find I from the given circuit. So two sources are connected, 24 voltage source and current source, and remaining all are resistors. So now in this find current I. So according to the given network, individual meshes are here 1, 2, 3. 3 meshes are there, individual loops here, 3 individual loops. So it requires 3 mesh equations. And if you want to apply nodal analysis, find out the principal nodes 1, 2, 3, 4. So from the nodal analysis also it requires 3 nodal equations. So to find the current I, easy technique representation and easy solving purpose, try to apply superposition theorem. So just pause this video and try to solve this one from the superposition theorem. According to superposition theorem, apply at a time only one source. So apply one source, other source is eliminated, then find out the individual responses, then total response is sum of individual responses. So pause this video, try to solve this problem using superposition theorem and later watch this video. Now here 24 voltage source and one current source, two sources are there. So two independent sources are connected in the given network. Now it requires two individual responses. First I am taking first individual response. Voltage source is connected here, 24 volts. This is 24 volts. And the remaining resistors are connected as it is. There is no changes in the resistor connection, but remaining sources are eliminated. According to the given network, remaining sources is here. Remaining source is nothing but only one source is there. That source is current source. Current source acts as a open circuit, so it is open circuited. Internal resistance of the current source is infinity. So current source acts as a open circuit. Now this is open circuited. And the remaining network is like this, here 8 ohms and here 8 ohms, 6 ohms resistor and 6 ohms resistor. If the current source is open circuited, this 6 ohms and this 6 ohms connected in series combination. According to the given problem, the required problem is here find I current through the 6 ohms resistor. This I am writing I dash due to one source. So now if the current source is eliminated, now the same current is flow through this path. That's why these two elements are connected in series combination. And similarly here 8 ohms and 8 ohms resistor. So this the current is through the 8 ohms and current through the 8 ohms. These two resistors current is same current is there. So these two elements also connected in series combination. Now the circuit is like this here. One 8 ohms resistor, one 8 ohm resistor, and here 6 ohms and 6 ohms. It is like this. So 6 ohms and 6 ohms. The voltage source is 24 voltage source is there. Then according to the given problem, we have to find out the current through this branch is here, this branch current is I. Now 24 voltage source is connected to this complete network, two networks are there, two networks are connected in parallel combination. So the potential difference between 2 points should be same here. So exactly at this point it gives the one voltage, that voltage is here 24 volts. So 24 volts is directly connected to this point here. Then we want here I dash, this 24 volts is connected to this 6 ohms resistor and 6 ohms resistor. So voltage across this point, these 2 points, and voltage across these 2 points should be same because both the elements are connected in parallel combination. Now I am writing directly I dash is equal to total voltage by total resistance. 6 ohms and 6 ohms connected in series combination, then becomes total resistance 12, then directly which gives the 2 amps. So now if the sources are eliminated, only one source is connected, then the simplification becomes very easy. Compared to the mesh analysis and node analysis, a simplification becomes easier. So one step is enough. Just redraw the circuit according to the given circuit here. According to the one source is activated, remaining sources are eliminated. Then redraw the circuit, then find out the response. This response is individual response. Now individual response I dash is equal to 2 amps. I dash is equal to 2 amps. Similarly, we have to apply second source here. So in this another second source is current source is there. Current source, and this source has to eliminated. So this source is voltage source, the internal resistance of the voltage source is 0, then the voltage source is short circuited, then short circuit these two points, then draw the circuit. So voltage source is short circuited, 8 ohms resistor, here 8 ohms resistor, current source is connected, then resistor 6 ohms as this, and here 6 ohms resistor is as this, 6, and these two are 8, and current through this branch is I double dash. Now I am assuming this current is second source, due to that source current through the element, that is acts as just like a individual response. That individual response is due to second source, so I wrote there I double dash. Now voltage source is short circuited. If the voltage source is short circuited, this point is directly connected to this point. This point is directly connected to this point, then these two resistors are connected in parallel combination, that is acts as a one single resistance, that is 4 ohms resistor. 8 ohms resistor, these two are now parallel combination because these 2 points are same and this point is same. In between 2 points, 2 elements are connected, so these two are acts as a parallel combination, so then 8 ohms and 8 ohms becomes here 4 ohms, and directly it is connected to one current source. This current source value is 2 amps. Then this side one resistor is there, 6 ohms resistor, and another side one more resistor, 6 ohms resistor. Then we want current through this branch, I double dash. So one current, 2 amperes current is dividing into 2 parts. One current is dividing into 2 parts. One path is 6 ohms resistor, another path is 6 ohms resistor. Equal resistance values are there. The current is also divides equally. But this current is flows in this direction. This current is flows through in this direction, and this side is in this direction. But we want current is in this direction. Opposite direction is required. That's why here I am writing I double dash is equal to minus. Minus symbol I am writing here because the current due to that source is opposite to the or assumption direction. According to the given problem, we want current through the circuit in this direction is required here. So downward direction. But according to the source, given source, the current flows upward direction. So the current is in opposite direction. That's why I wrote here minus. Apply current division theorem. Total current into opposite resistance by sum of two resistance. Then it becomes here 1 amps. So the 1 amp means minus 1 amp because minus symbol is there. Minus 1 amp. Then write total response. Individual response is here minus 1 ampere and here 2 amperes is there. Then the total response I is equal to, total response is equal to summation of, algebraic summation of individual responses. One is I1 is here 2 amperes minus I double dash is minus 1 ampere, so minus 1 ampere. Then that current through this branch from the two, using two sources, that I is equal to 1 ampere, so 1 ampere. To solve these type of problems, superposition theorem is the best technique to find current or voltages, and superposition theorem is not used to find to determine power. So only voltage and current parameters purpose superposition theorem is used, and according to the given network, here superposition theorem is the best technique. So note down the solution of this problem.
Thank you very much guys for watching all the videos. So far what we have completed, let's discuss about it now. Over the screen you can watch SAIMEDHA.in app. If you open the app guys, you are going to see there. Let's talk about the store now. In some other branch, let's open a EEE branch guys. In the EEE branch you can see the content. In the content engineering, in the engineering we have electrical circuit 75 videos there. In that machine nodal analysis, if you open, you can see there we are having around 11 lectures guys that we have completed. Then practice set 1, practice set 2 with solutions, questions with solutions, practice set 3, questions with solution, previous ecet questions with solutions, and at last we have what machine and nodal analysis practice sets. So what we have covered guys, we have completed all the basic to advanced level video lectures. Then we have completed the practice set 1, set 2, set 3. Each set is going to have around 20 to 100 questions there guys. Based upon the topic marks, it is going to be there in the not only in ecet but also in the government jobs and PSUs. And at last you have there an online test examination also, in order to check the time management what you need to utilize in the competitive examinations. So this is so far we have completed guys. Now you can watch over the videos. It can be utilized for, it is useful for not only the ecet examination but also for DRDO, sub engineer, assistant engineer, Telangana State Public Service Commission, Andhra Pradesh Public Service Commission, BHEL, NTPC, IOCL, Staff Selection Commission, JEE. I remind guys for EC, EEE and civil, this SSC JEE will be there every year twice. So make sure you utilize all the video lectures to prepare for this examination also. And everyone knows about the Railway Recruitment Board Junior Engineer and as well as ISRO guys. If you people are interested to watch all the full length videos in the SAIMEDHA.in app, make sure you save this number. This is in charge sir Shashikant Valmiki sir number guys, 98486925998. Give him a missed call, give him a call guys for any details, for any updates. Every single day we are updating the videos, material, and as well as what a competitive level examination practice set papers also. Thank you very much guys. I wish that you have watched all the videos. If you haven't watched so far, go and refer all the videos guys. Thank you very much. This is Mohammad Inzamam signing off.